model is that used to generate new examples. So we need a model that will be creating the example. And discriminative model is that determines whether a newly generated instance is a fake instance created by the generator or it is a real one. So it is just telling me yes or no, whether it is fake or not fake. And generator model, the task of generator model is it is generating new examples. So based upon the result of discriminative model, it try to create a new example which are difficult for the discriminative model to understand to mark it as a fake. So these two systems are combined in such a way to create a network. That network is called generative adversarial network. So, in such a way that these two models train each other. So, these two models work in opposition of each other. So, one system try to create the sample, new example, and discriminative model is just checking whether the new sample is similar to input or not. It is telling us whether it is fake or real one. So GAN network is just like a game in which two opponents are playing against each other. So input to the generative model is just a vector of fixed length. Okay? Now how it works? So we have generative model and we have discriminative model. The input to the generative model is just a vector of fixed length. This vector represents any object in terms of its feature. So every object, whether it is an image or it is a text or it is some audio, video, whatever it is, so every object have its feature. For example, this image, to represent this image, I can represent it with some set of values and each value represents some feature. For example, this first value may represent the long hair, this value 5.4 may represent the blue hair, this value 3.5 may represent the mouth open. So different features of the image are extracted and then based upon this feature the deep neural network model is trained and deep neural network model is try to generate the try to find out the pattern and generate the similar image. So initially, to start with, initially this vector is filled with some random numbers and as the system is trained, these numbers are being changed based upon some error values that are being generated and based upon the error the values are changing and changing and changing and finally we train the system to generate something based upon the input data. So this model is trained during which it learns to create the new vectors. So for example, we have neural network generator, we pass it the set of features and based upon this feature it will create image. So if the features are like this, the image will be like this. If the input feature is like this, then image is like this. So it is just a neural network generator. So based upon the feature, it is going to generate some new images. Similarly, same thing can be done with the sentences also. Sentences are converted into the features. These features may include, for example, if I have a sentence, this model is, then every sentence has feature. For example, this sentence consists of 10 words and this sentence, this word is of 4 characters, this word is of 5 characters, model is the next word, is the next to next word, and for model this is the previous word, and for is this is the model is the previous, and so on. So all these are the features of this particular data, and these features are represented in the form of some numeric values and then passed to the neural network generator, which produce the output in the form of sentences like if we have this kind of feature, then the output can be how are you. If we have this kind of feature, then output can be good morning, and so on. So this is how you train the neural network and how it works. Okay. Then we have discriminative model also. This is the model which checks the output and which tell us whether the output is real or fake. So we have a generative model that will accept some features and generate an image or generate a text, and we have discriminative model also. The purpose of discriminator to check the output given by the generative model to see if it is real or fake. So we provide the image. Discriminative is basically a neural network or it is some mathematical function which tells us some value, which give us some value, scalar value will be there. If the value is large, that means the image is real. If the value is small, that means the image is fake. Okay. For example, I put this particular image, discriminative produce the value 1.0. This means this image is real one. So this discriminator producing 1.0, this means discriminator, this image is real one. Similarly, if I input this kind of image and discriminative tell me, give me the value 0.1, this means this image is fake image. So all the lower value means fake image, and all the upper value, larger value, this means real image. So we can set a threshold as per our requirement. It can be 0.6 or 0.7 or 0.8, whatever you want. So according to the requirement of the scenario. So we can also set the threshold that above this value we treat it as a real, and below that particular value we treat it as a fake. Okay, now we have two kind of network. One is generative network, another one is discriminative network. To train this particular network to particular model, data must contain both the real and the fake samples. Okay? The fake samples are generated by the generative model. To get the fake sample, we have a generative model, but we have to provide the real samples ourselves. So we must have the collection of real samples with us. Fake samples will be generated by the generative model. And to train the GAN model, we have to set up both the above models. We have to set up the discriminative model as well as generative model so that they can work with each other to improve the efficiency of the network. Now to understand this particular setup, let us consider an example. Suppose a man wants to start a business of selling the spices. Now that man, what it is doing is, that man will buy the spices from the spice manufacturer and sell them on. Now this man will have to identify whether the spices is pure or adulterated. So the manufacturing company can give him the pure spice, or it can provide him the adulterated spice. Okay. So if he is getting the pure spice and selling that spice, then it will generate the money. If it is getting the adulterated spice from the manufacturer and selling that spice, then it will not generate the money, then it will go into the loss. Okay. Now when the adulterator initially bring the adulterated spice, shopkeeper may catch him. So we can easily identify that this spice is not the real one, it is adulterated. So then what adulterated have to do? Adulterated will change his method and adulterate in a different way. That is, he will improve his adulteration in such a way that they will look exactly like the real thing. On the other hand, what shopkeeper need is that it will also get the feedback from his customers, whether customer tell us, okay, last time what spice I purchased from you, that is not good quality. So he will also make the method of finding the adulterated spices more effectively. So what shopkeeper required is a effective method to find the adulterated spice, and what adulterated required is an effective method to create more to create the adulterated sample which looks like more the real one. So adulterator aim is to make his technique such that his spices look like the real thing, while the shopkeeper aim is to be able to differentiate between pure and adulterated spice. So this is a mutual competition between the two. That is the principle behind the GAN. So we have a discriminative, so our shopkeeper is discriminative, and our adulterator is basically generative. So we have generative model and we have discriminative model. Generative model try to generate the samples which are more near to real one, and discriminative model improve itself to try to catch all the fake samples that are being generated by the generator. So in this competition, in this particular game, both try to improve themselves. Discriminative also improves and generative also improves. So finally, this is the pictorial diagram that we have. We have random variables. We have random variables that are passed to the generator. Generator create a sample, and that sample is transferred to discriminator. Now discriminator have two kind of samples. Some samples are the fake sample and some samples are the real sample. So based upon these two samples, discriminative is trained to find whether a given sample is real or fake. So whatever the loss that they obtained, that loss is used to update both the discriminator as well as the generator. So that loss function is being used commonly by the generator function or as well as the discriminator function. We start with the random variables and try to generate a sample. That sample is passed to discriminator. Discriminator really easily find out that this sample is fake. So according to the loss function, generator will be updated and it will try to generate the new sample. New sample is passed to discriminator. Now discriminator requires the real sample as well as the fake sample to improve itself. Okay. So based upon the improvement, when all the system improves, what we will do, we will remove this part. We will remove this part. So this part will be discarded. This part will be discarded and we will retain only generator. When all the training happens, generator is trained in such a way that now it can generate the samples which are almost equal to real one. We can extract generator from here and use it in any task that we want to do. Okay? So this is how it all works. The generative network keeps generating the sample similar to the real sample, while the discriminative network try to distinguish between real one and the fake one. So ultimate goal is to create the generative network that can generate samples that are similar to the real one. So once this happens, we remove everything and we just retain the generator part, which are plugged into different applications to generate the samples that are required in that particular application. So this is the training part. This is to show you the training part of this network for generating the cartoon faces. So initially it takes a large amount of data and large amount of time to train this kind of network. And after 100 iterations, you will see the images like this one. Very blurred images will be created by the generator. And after 1000 iterations, now you can see our generator is generating little bit something that we can understand, but the system still not able to understand these images. And after 2000 iterations, system is still struggling. Similarly, if we increase the iteration after 10,000 iterations, now system is able to generate somewhat similar to the real images, but still the images are blurred and they are not good, visibility is not that much good. And after 20,000 iterations, so you can see as the number of iterations are increasing, system is understanding more and more about the images, and it is creating more images that are like the real ones. After 50,000 iterations and new faces developed by the trained models, you can see now these faces are almost similar to the real one. So real one faces, and now our system is trained to generate the cartoon faces. Once the system is trained to create the real faces, it can be used in any other scenario where the cartoon faces are required. Okay, so training a GAN model is not an easy task. Both a generative and discriminative model cancel each other out. This model has to be trained for a very long time, and during this time no good output is produced. Many times the productive model keeps creating the same sample which does not improve the model training. So that is the bottleneck in these kind of networks, and we need to take care of these networks. Accuracy and coverage are opposite to each other. Accuracy means our system is producing 80-90% accurately, but the coverage can be limited. For example, in cartoon face generation, it is able to generate only few kind of faces only. It is not going to create every kind of face, but that is basically coverage. If it is only limited to some kind of faces, to generate some kind of faces, then its coverage is small, but it is possible that the small amount of faces that is being generated, they are very much accurate. So accuracy can be high, but coverage can be low. So as one increases, the other decreases. This is the common scenario that we face. If we try to improve the accuracy, we need to reduce the coverage. And if we try to increase the coverage, we have to reduce the accuracy. So it is very important to balance both the learning models. If the training of discriminative model is bad, generative model will also be bad. So you cannot expect that generative model will perform good if your discriminative model is not good. Okay, so these both are working in connection with each other, and you cannot say that one perform better and another does not perform better. That will not happen. Okay, so now different kind of generative AI are possible, that are being developed and that are already developed. So first is unimodal system. Unimodal system means trained on one kind of input. For example, the system that is being trained on text only, or image only, or audio only, or video only. And we have multimodal system. Multimodal system means they are trained on more than one kind of input, like they accept image as well as text, or they accept audio as well as image. Different combinations are possible. So that kind of systems are called multimodal system. Also classified based upon the type of data. We have text generation, we have image generation system. ChatGPT is our text generation system. Similarly, we have speech generation system, we have video generation system, and we have some other kind of system can also be there. So these are different classification of the generative AI that is being researched in these days. In 2017, transformer model was introduced, which revolutionized the word formation. So whatever you see, like in ChatGPT or Gemini, so the base of those model is basically this particular model, transformer model, which is introduced in 2017. And based upon all these GPT models were created, which are the basis of the popular product that is called ChatGPT. We all know how it works. These models are based upon very large language model from which a variety of tasks are taken. For example, uh, tasks that are related to text, that include the text generation, that include the machine translation, that include the summarizing the text, machine coding. You can create the code in Java or in Python or any language. Then we have chatbots. Then we can generate the question papers also. These days, most of the faculty members, they are creating the mid-semester exams or final exam question papers using these text generative models that include ChatGPT also. We have grammar checker and spell checker. We have research papers like Casper AI and Jenny AI. These are the AI technologies that helps to read the research paper, to summarize the research paper, to find what is written in that research paper, to review that particular research paper. So all these tasks can be done with the help of text generative models. Similarly, we have audio or speech related models also that include speech understanding, speech to speech translation, speech to text, text to speech, and sentiment analysis from the speech data. So whether the spoken data is about spoken in the angry way or humorous way, or whatever the way, whatever the sentiment that include. So this is the way they are going. So for such tasks, generative machine learning use the large language or speech model. Here large refer to both model size as well as data. So model size is also very large. For an estimate, ChatGPT 3, currently it is working on version 5, but I am talking about version 3 model. It has about 17,000 crores parameters which are trained, and it requires 570 GB of memory. So this kind of hardware, this kind of requirement, that is not possible with a common researcher. So only the big large companies can do this. It requires a lot of infrastructure to train this, and it has been trained upon about 30,000 crore words. So you can easily imagine. So how much data they have to collect to obtain 30,000 crore words. So how much memory it requires, how much infrastructure it requires. So it is not easy task. And we are just talking about 3 ChatGPT version 3, and version 5 is much more than this. So these words have been collected from various sources such as books, web pages, Wikipedia. So whatever the source they get, they collect the data from those sources and use that data to train the system. Only then they are able to create this kind of system which can generate data, which can generate text in such a beautiful manner that is being generated by like ChatGPT or Gemini. है ना? So after training the model, it has to be fine-tuned also. Now just training the system is not sufficient. So there are the questions which are which are required to be answered. And for example, if I have a question, what time is it now? Now, no training will work for a question like this, whatsoever training you have provided. So, you need a separate program that will identify the question, so what is this asking? And because, for example, I am asking about time. Now, the system will get the time from somewhere, maybe a system time, and combine it with some text and then present it to the user. So for all these things, a separate program will have to be created to answer this kind of questions. So which will be combined with the output of the model to form the final answer. So model will generate the output, and that output need to be combined with some another text and to form the final answer. That is, the technology will have to be created for the task for which the model is to be used. So they have generated ChatGPT. Now what ChatGPT can do, it can produce the output. Now we need the system that will identify the prompt. So we system, what user will do in order to create a chatbot, user need to enter the prompt. Now we need to understand the prompt, what is being asked, how it has to be retrieved. Then based upon that understanding, ChatGPT will extract the text, and that text will be present in such a way that the end user feel that he is communicating with some real person. So all this can be done with the help of another separate program. So that means we need separate program. So we use the model as just as a tool in this case. Okay. Now this is how, this is some of the application of the GAN, some of the uses of the GAN, how it can work. So there is an image to image translation. There is a paper that is published by Isola, and that paper is about image to image translation. That is, we can make a zebra out of a horse. We can make a colorful picture from an outline. We can colorize a black and white picture. So all these kind of tasks can be done with the help of GAN. So as you can see, so this is the input and this is the output. Input and output. This is the aerial map as input, and output is your outline. So this is input and this is your output. This is black and white input which is being colorized in the output. From the line diagram we can create the final image. So these kind of tasks can be done with the help of image to image translation, and the start of this kind of task is basically this paper is the base paper for this kind of task. Similarly, we can generate text to image. You can give a text, based upon the text system will create an image. In 2016 again, generative adversarial text to image synthesis, that is the paper presented by Reed, and they can create the image from the text description. As you can see, this is a flower with white petals and purple white anthers. So based upon this text, system is creating the flowers which have white and purple color. The petal of the flower are maroon in color and have green leaves. So system is generating this kind of image. So you can see the image is very much near to the description. So this kind of task can be done with the help of GAN. Similarly, text to image synthesis. We can create the images from the text description as done by the Copilot or Gemini. A bowl of soup, that is a portal to another dimension as digital. So you give a prompt, this is called prompt. So you give a description of the picture and system try to create that kind of picture which is similar to the description. Now face aging, another important paper in this particular field. Antipov in 2017, face aging with conditional generative adversarial network. So this is the original picture and this is the generated picture. All these are the generated pictures based upon the age, based upon the age 10 to 18. So this image will look like this one in the age group of 10 to 18, look like this one in 19 to 30, and from 30 to 39, 40 to 49, and 60 plus. So this is how it is generating the picture. You can see uh, this is again a big deal in the case of GAN. Very wonderful work that is done by Antipov. Human face generation that we have already discussed, this face does not exist. The base paper of that particular is progressive growing of GAN for improved quality, stability, and variation. So you can create the faces of the human, as much faces as you require, you can create those faces. Again, realistic photograph generation. Andrew Brock in 2018 present a paper that is large scale GAN training for high fidelity natural image synthesis. Natural image synthesis. So all these images are fake, but they are synthesis by the computer system. Peacock, this is dog, hen, some chest, mouse. So all these pictures are being generated artificially with the help of GAN network. So the base behind all these systems is basically your GAN network. Then we have creating the frontal view from the face. So we give the side view is given. Based upon the side view, system is automatically creating the front view and all other views. Okay. So this is again done with the help of GAN and resolution improvement. Given a blurry picture, system will automatically improve the resolution of the picture. As you can see from the blurred picture, system will automatically generate the crispy picture, high resolution picture again with the help of GAN. So technology behind this is again GAN. So you can create 3D models also. Another paper that is learning a probabilistic latent space object. So what we are doing is from nothing to creating a 3D image. So you can create a 3D model based upon some input and again this generation will the help of GAN. So GAN network is behind all these generations. Similarly, in the field of audio and video, apart from pictures and words, similar model have been created for sound also as well as for video also. Today we can listen to new songs in the voice of Muhammad Rafizi. So Muhammad Rafizi, as we all know, there is no more in this world, but the systems are being trained using their voice, and you can open this particular site and you can see yourself that the songs, they although they are English songs, but they are being sing in a voice of Muhammad Rafizi. So I would like to show you the website also. Uh, Let me show the website. This is the website. I hope my screen is visible to everyone. So this is the website. The link is already given in. Uh, so this is the link www.jamable.com custom Muhammad Rafi. So if you see the website, so here is a song. Is it audible?
No, sir.
It is not audible. Mm,
No.
sound.
to feel your heart beating next to mine. Won't you come on down?
Now,
Forget about your past.
Yes,
You
sir.
can't take my hand.
is it audible now?
Yes, sir.
Ah, so you can see, although it is English song,
Yes,
but the
बेटा.
voice is of Mohammed Rafi.
हाँ.
So
आंटी बनता भी नहीं है यहाँ पे बेटा.
similarly, if you scroll down, we can have another voices like voice of Sonu Nigam is also there, and voice of other singers of Indian that is also there. So you can create a voice like this one using the GAN system. So system have been created that allow us to imitate anyone's voice. So that is possible now with the help of GAN. Similarly, uh, in the video field also, lot of things are happening. Content in video game is being created with generative models such as the landscape of the scene, atmosphere, non-playing and static characters. All these are being generated by GAN. So new videos can be created by changing the existing video or combining it with another video, which is called deep fake. Now it is very concerning factor. Deep fake. Let's see what it can do to us. Deep fake is basically the deep model and the fake learning. It is combining two terms, deep model and fake learning. Earlier these models used to work on the same type of data, but they started using different type of data, that is by combining the text, audio, video, and the content of deepfake can be in any form: someone's face, someone's voice, someone's background, someone's body. Initially these were made for fun, but now they are being made with a malicious intent also to harm someone or to deceive someone. So this is the classical example of deep fake. Let us see you can identify or not. So on the left side we have real sample and on the right side we have face swap sample.
I don't believe it.
Believe it.
I hope everyone can recognize the original as well as the fake one. So the original face is of the famous actor, that is Gal Gadot, and the swapped face is again of the famous actress that is from India. So this is how face swap can work. Okay. So this is the site github.com deepfake face swap. They contain the open source code, and you can download those code and you can try themselves to swap the face. So the face, it is available on GitHub deepfake face swap. Okay. Another site is there, github.com, that is available, that is Deep Face Lab. Deep Face Lab, that is again similar kind of videos you can generate. It is again all the technology behind this is GAN technology. Now again this is another video. Listen to this video.
hardly work. I'll never believe that you live on a salary. A year ago, you drove an old car and lived in a small apartment. How did you manage to change all this?
Just a year ago, for me, it was like a previous life. Now I live in a cottage in the countryside. A month ago, I bought an apartment to rent out, and I got rid of my old car a long time ago. Now I drive a new Land Rover, but I work a lot, so don't accuse me of being lazy. I understand your surprise, but I advise you to start living differently.
It's easy for you to give advice. And I have to suffer every day at work to support my family. And you know what? I always run out of money anyway.
What's the problem with starting to think differently? Accept the idea that work is not the only way to make money. When someone tells me I just got lucky, I laugh in their face because today everything is on the internet to get rich without getting up from the couch.
So you're saying everyone can make money like you? I don't believe what you're saying.
Don't you believe me? Give me 20,000 INR and I'll earn $1 million in 3 to 4 months. It all depends on you, whether you want it or not.
All the viewers saw that you showed me the website where you...
So as you can see, the previous video, this is basically a fake video that include a host and the famous personality from India, that is Narayana Murthy, and it is alluring you to use some fake website or some fake app for the investment purpose and assuring you that you will be rich within 3 or 4 months. So this is the fake video that is available on the Facebook. It is circulating on the Facebook account. So I also see this video in my account and download it, and you can easily find out that this video is fake one, because there are some glitches in the expressions of the Narayana Murthy sir and glitches in the expression of this anchor. But because we are the person, we have technical background, we can easily understand these kind of glitch. But the person without having some technical background or some elderly person, they may not be able to find out these kind of glitches. They may not be able to notice the fakeness of this video and easily fall in the trap of this particular advertisement, and they can be a victim and they can lose their money, and sort of all kind of things can happen to them. So this is again the bad side of deep neural network. You can say GAN network. So GAN network are there. They are for generative purpose, but the people now are using them to generate these kind of videos, fake videos. Another example, let me show you. This is reenactment. Reenactment means the expression of one person is transferred as the expression of another person. So one person is creating the expression and the same expression is transferred to the other person. Now, after watching the video, you can easily guess yourself what kind of problem it can create. Let's watch the video first. As you can see, so this person is creating the expression. Same expression is transferred here, as you can see. I hope everyone can see.
Yes, sir.
So what it can do, there is a source actor and there is a target actor. We want to transfer the expression of the source actor into the target actor. So you can see whatever the source actor is doing, the same is doing the character as in the result field. Actual character is this one, but result is doing something else. So this kind of technology, although it is very interesting, but it can generate a lot of problems. So this is basically reenactment. So again, the technology behind this is generative adversarial network. So a lot of things can be done. So we need to fight against this. There can be many ways to fight. There can be many ways to fight against deepfake. One is to develop a technique to catch it. So there is research being done in order to find whether the video or audio is fake or not. So So these techniques detect the irregularities in the video and sound patterns, and these techniques need to be made more effective. So it is again discriminative model basically. So it is trying to find whether it is fake or not. Generative model is creating more and more models, more and more output that is real one, and discriminative model again need to be more effective to find out whether the output is real or fake. So as our technology advances, we need to advance both of them. So to identify the authenticity of the video, we can use the watermarks also. But perhaps the best and most effective way to make the general public aware of it. So before accepting any image, any video or word as a true, one should investigate its source, context, and using one's own investigative thinking to understand the content in it. And for safeguarding, multiple methods should be used instead of a single method. We should not rely on a single method. We must authenticate everything from the multiple sources and multiple methods. So GAN is basically an emerging research topic. Architecture of GAN is flexible and can be applied to a wide variety of problems. It is not necessary that the GAN model will provide a solution for your data. It is not possible, not necessary. It is theoretical foundation need to be further strengthened, and the evaluation of GAN model is still a research topic. So this is very much upcoming area, very much potential is there. So the new budding researcher, they are required to see all these things, because generative model is getting more and more strength these days, and they are creating more and more output which is almost real one. And to counter the threat of the generative AI, again we need the models that can identify all these kind of things, and there is a lot of potential of research in this particular area. Explainability is another area where we need that the whatever the output being generated by the model, that that output should be explainable, so that if we need to do some legal action, then it can be proved with some explanation, so that it can be decided easily for judges. It should be easy to decide about the problem. So explainability, it is another field where we need the research. GAN model, again upcoming model. And so I hope that is that you understand what a GAN is, what it can do, and what are the various areas where it can be used. And that is all about my first part. In the part 2, we will discuss about building some LLM app that can see, think, and integrate. So that is all about my first lecture. Let's have some break, and then we will start within 10-15 minutes again.
Sure, sir. Sure.
Thank you.
You very much. It's very knowledgeable session, sir. Thank you.
Thank you, ma'am.
So after 10 minutes, we will again restart our session. So all the participants are requested to please again rejoin after 10 minutes. Thank you very much. So after the session, there is a question answer session there. So all are requested to please note down all the questions that we have required to ask our experts. Thank you very much.
Multimodality means we have different kind of data. It can be images, charts, videos, sensor data, or it fails on the structured task also, where we have to create the input for the databases, workflow, and we have to automate something. For these kind of tasks, simple text in and text out or text only AI will not work. For example, there is another scenario like doctors upload the X-ray image and symptoms. Again, it is a multimodal system. X-ray is an image and symptom is a text. And what is expected by the doctor? That system will relate these two things and produce some meaningful output from these things. So simple text-based systems are not capable of doing this. Simple chatbots are not capable. Although we have the chatbot, we have generative AI for chatbot, we have generative AI for images also, but we need the system that can accept the multimodalities. Multimodality means the input will be of different kinds. So we need to stack different capabilities to drive the real value to the business. So we need the app that can perceive, that can reason, and that can act according to the problem. And that means we need to integrate three powerful capabilities of generative AI. One is to see. That means multimodal input should be acceptable. Understanding the images, understanding the documents, and other known text data, system should be able to understand whatever it we fed to it. Then system should be able to think and produce the structured output, reason through the problem, provide the reliable and machine readable answer. That is the think part of the system that we need to integrate. And finally, integrate the end tools that we want to use. It can be actions, it can be APIs, whatever the AI generate the response, that response should be such that it should be able to be accepted by the next program as an input and trigger the action according to the requirement. So we want to integrate the triggering program along with this all things so that we can create an end-to-end solution for a given problem. Okay, so let us discuss with detail one by one. We have three capabilities. The very first capability is the requirement to see. That means the system must be able to get input, multimodal as input. That means we are, while using this, while providing this, we are giving our application an eye. So eye that can see the images, eye that can see the text, that can read the text, eyes that can read the images or audio, it can be anything. So the ability to process and understand the multiple types of data like images and text in a single prompt. And why it matters? Because the world is not just a text. Business problem involve the product photos, involve the invoices, involve the charts and the diagrams. So in reality, we have the business that involve multiple kind of input. Example is analyzing a photo of damaged product alongside the customer's written complaint. So we have to analyze both the things and to understand the scenario and then act accordingly. Now, second capability is about thinking. Thinking means moving from conversation to conclusion. So system should not just parroting the text, it should actually analyze the text, able to analyze, able to infer, and finally solve the problem. And what does this mean? That means forcing the large language model to provide its response in a predictable, structured format like JSON instead of the plain text. So we force the system to produce the output.
Excuse me, sir, please share your screen. It's not visible, please.
The screen is not visible? Oh. How it is visible?
Yes, sir.
Okay. I am assuming that my screen is visible to all. So I go through all the slides. So should I go back or continue from this place?
Sir, please, I continue, sir, please.
Let's continue. Okay.
It would be better, you may please recapitalize the back one, sir. Yes, sir.
So,
Please, sir. Thank you.
Okay, so we are talking about building LLM apps that can see, think, and integrate. So main focus is upon developing the application that can see. See means we can view the multiple inputs, multiple forms of input. Like it can be text, image, or audio, video, anything, and then think upon it and then integrate. So that I have already discussed, that text in, text out. That is a simple scenario for any chatbot. It accepts the text and produce the text output, but it is not sufficient, because in the real world we have things like this one, where we have image along with the uh, we have image along with the text, like customer review. Now the customer review is not directly related to the product. The product is visible in the image, problem is also visible in the image, but the review is that simply waste of money. So this review does not convey anything about the problem. So we need a multi-model where we have both kind of, it can accept both kind of input and act accordingly and understand what the problem is and act accordingly. Uh, then we have this again limitation that we have discussed, that simple text only mode can work in some cases, but it will not work in all the cases. Then we have different capabilities we need to integrate. One is the capability to see something, one is the capability to think, and capability to integrate. To see something means to give our application the eyes. That means our application must be aware of the images or the text or different kind of inputs. It can be audio or video also. And similarly, for structured output, we need to just move from the conversation to conclusion. So whenever you use a text-based chatbot, those chatbots are in conversation mode. You ask something, then it replies something in the form of text, then again you ask something. It is again text-based. But now we need the system that can move from conversation to conclusion, and that means it should be able to analyze, infer, and solve the issues. And why it matters? Because structured data is reliable. If your system is able to produce some structured data and in the consistent manner, means every time you prompt it, it will produce the same kind of output, then it is very useful for the other software. It eliminates the guesswork. For example, if your system is producing the output, the review seems bad, and this particular text is not usable by the other software. But if your system is producing a JSON format like this, sentiment is negative and issue is manufacturing quality. So based upon this value, we can create a program that can be triggered. Yeah, so when the system sees this particular value in the output, it will trigger a program that will initiate the refund process, or that will initiate the replacement process. So that kind of task can be done. So that integration can be done only if our output is in the structured format. So that means structured format is reliable and it is consistent. It should be consistent. Only then it can be used by the next software in the downstream. And then third part is the integrate. Integrate part is important part, connecting the brain to the hand. Instead of unstructured text output data that system can use directly, uh, we need that data basically in the structured form. So that means if we have structured form data uh, uh, from the think phase, basically we can trigger the real world action based upon that particular data, like calling a function or calling an API. This is how the AI analysis turns into a business outcome. This is the final step that creates automation. So automation can be done only if we have structured data. Okay, so the sentiment negative, for example, the sentiment is negative. So based upon this particular value, output automatically triggers a function to create a customer support ticket or some refund for program or some replacement program, whatever you want to perform at that point. So we can do that only if that part is possible. If just we have structured data as output. So we have three things. We have to well, the application that can see, that can think, and that can integrate. So let's see how this can be done with the help of API, with the help of existing generative AI. Let us understand what is multimodal. Multimodal means representing the different kind of inputs into a single representation. So that is multimodal. We convert the different kind of inputs. So every input is converted into numeric features, and that features are called embedding. That are called embedding. And then we combine embedding of all the different modals. Modal can be audio, it can be video, it can be image, it can be text. Then we can combine the modals of embeddings of all the modals and create a common embedding vector that can be used for training the system. So we have two options to combine these embeddings. One is called joint representation, where the single unified representation of different types of information, which could be text, which could be image, video, whatever it is, we combine the embedding of each modality in a single embedding dimension space. For example, if we have text data and we have image data, we have the system that can be used for encoding the text, that is called text encoder. Similarly, we have image encoder that will accept the image and convert it into the feature vector, that is called embedding. And the feature vector of text data and feature vector of image data, both are concatenated by different technologies. It can be concatenation, it can be tension mechanism. Different technologies are there to combine these two features, and then they are passed to neural network for the joint learning, joint representation based upon some objective functions. We train the neural network. Now this neural network is trained upon the joint input, and now it can understand text and image both. So we can do this part. Secondly, this is the kind of encoders that we can use in our encoder part. In the previous example, like this one, text encoder and image encoder. For the text encoder, we have different existing technologies. It can be BERT, it can be GPT, Roberta. So these are the current state of the art. You can use any of these to get the text embedding. Similarly, for image, we have CNN based model. These models are transformer based model and or RNN based models, you can say, and these are the CNN based models. ResNet ho gaya, VGG is there, efficient net, vision transformer. Then for video we have I3D, C3D, slow fast network. For audio, similarly we have WaveNet, MFCC, and for sensor we have LSTM, CN, and different kind of encoders are there. So according to the kind of input, you can select any encoder from these and get the embedding for that particular input, and use that embedding and concatenate those embeddings, and then use those embeddings to train the system. And we have another approach that is called coordinated representation. In the coordinated representation, we learn independent representation alone and then coordinate them together in the fusion stage. Okay. So, for example, we have text encoder. It has its own objective function, and we pass the text data, and in the text data we get the encoding. After training this system, we get the encoding from this data. Similarly, we have separate systems for the images. After training this system, we get the encoding from the image encoder, and to our new text and new images, we get the pre-trained weights from this system as well as this system, and we get the text embedding and image embedding, and finally we have objective function. So in this approach, each modality is handled by a dedicated model. So this is a dedicated model for encoder, and this is a dedicated model for decoder, which are trained separately and may also have its loss function and objective function. The difference from the previous case is that the training part is common, but here the training part is separate. So this is how you can use different kind of representation for the C part. Then we have think part. The think component, the task of this component is for orchestration and structured output. This is called the brain of your application, where LLM makes the decision and format its response in a predictable way. So orchestration part and structured output, these are the two different sub-tasks that is performed under this component. Orchestration involves managing the logic flow. For example, LLM first analyze an image, then decide if it needs more information or not, then formats its findings. So the framework like LangChain and Llama Index, these are the libraries of the Python, and that can be used for orchestration part. These are perfect for this kind of task. They help you to build the chain or agents that connect the different steps. So first of all, we need to get the image. We need to decide whether it need to be combined with the text information. Then whatever the output, output should be in the structured format. So all this can be done with the help of LangChain. You can say module that will be available in Python. Then the structured output part, which is the crucial for making LLM response usable. If you are not creating structured output, then your response may not be usable by the end product. So instead of getting back the plain text sentence, you are forced the model to reply in a structured format like JSON. So this is often done by providing the model with a schema. So you need to tell the system what kind of output you need, what will be the field in that output, and for that kind of information, that kind of schema, you can use the special class available in Python that is called Pydantic. So that ensure the output is reliable and machine readable. So only if you provide the data in the form of JSON, whatever the text output produced by the LLM model, you need to convert that text output into the JSON for you. Ask your LLM to provide the output into the JSON format. Otherwise, your system will not work. Your third part will not work. So if you use raw API like OpenAI is there, Gemini is there, Hugging Face is there. So they all provide the APIs for the product for using them. Open API is the paid one, but Gemini is also provides the free API. So to use for the limited use, and Hugging Face is also providing the free for some limited use. And you have if you are using the raw API, then you have to handle the prompts manually. You have to pass the JSON yourself. You have to manage the chaining of the steps like analyze, then summarize, then store. You have to do all these things yourself. And connecting the AI output to your database or the app logic. So there is a mess of everything. So one side we have API, one side we have JSON, we have a front end to handle, we have a back end to handle. So if you are not creating a stack of all these things, that is see, think and integrate, then all these things have to be very cumbersome, and it will be a very big program to create. But by using the technologies, by using the capabilities of the Python, all these things can be done in a few steps that we are going to discuss in this particular session. We need the framework like LangChain or Llama Index. The focus of LangChain is on orchestration. That means it provides the chain which link multiple reasoning steps. Then it provides the agents that let the model decide which tool or API to call, and then memory, conversation, state across the interaction that has to be maintained, and we need the memory for that. Example is take the customer complaint, call the vision model, and pass with JSON, then store in database and suggest next action. So to implement this particular chain, we can take a help of libraries of the Python that like LangChain, and similarly we have another library that is called Llama Index, that is for data integration. It provides the indexing services, it provides the retrieval augmented generation. That means LLM can see the external knowledge when answering. Sometimes we don't have the knowledge in the database, that knowledge is available on the website. So using Llama LLM can query the real-time websites and get the data from there. And we have query engine, structured query across the multi-model. Example is fetching the product specs from the company database to cross-check the customer complaint. So if we need that extra information, can be obtained by the by using the libraries like Llama Index. Then come the integrator part. Integrator part is to use the function calling. This is how your application take action in the real world. Modern LLM supports function calling or tool use. So you can give a list of the tool to your LLM, which is basically the Python function that it can use. So LLM does not run the code itself. Instead, it outputs a JSON object that specifying which function to call and what arguments are to use, and your application code then execute that particular function. For example, you could give the LLM a tool called get current weather and location strings. You can create a function in your Python code and inform the LLM to call this function if someone asks what is the weather like in Mumbai. Then what LLM will do? It will request to call this particular function and passing the value Mumbai from the prompt. So LLM will extract the information from the prompt that the user want to get the weather and the city. So these two information that user want to get the weather and of Mumbai city. So based upon this information, it calls the get current weather function, which is already defined in the Python. And while calling this function, it pass the location argument of Mumbai to this function, so that this function fetch the information of the Mumbai, weather information of the Mumbai, and pass it to the end user and present it to the end user. So now coming to our case study, Visual Product Review Analyzer for an e-commerce platform. Our goal is to create an automated system that can analyze a new product review, which includes an image and text both, and then decide what function to take, what action to take. Action can be flagged for moderator. It can be add to a positive testimonial list or alert to the inventory team. So any kind of action we can define, and system will perform that action based upon the result of the analysis of a review as well as image that is given by the user. So in this case study, let's divide it into three parts. One is the C component, which is multi-model input, because our input have two parts. One is the photo part, another one is the text part, that is written review from the user. Photo is also uploaded by the user. So system will receive two inputs and application will send both the images and the text into the multimodal LLM in a single request. Then in the think component part, we will prompt the model to analyze the image and text together to determine the review sentiment, identify the specific product issue, and categorize the defect. Then we will produce a structured output into using the pedantic library in the Python, and you force the model to return the JSON object. So that in the predefined structure, we will define a structure and force the model to produce the output in the form of JSON, so that can be used for further action. Finally, we will go to the integrated part, where we will trigger the function, or we will use some tool based upon the suggested action of the structured output. Application take a real world action by calling an appropriate function or API. So action executed means, for example, if suggested action is flag for review, system call your internal flag review for moderator function. If the action is positive review, then system call the function add testimonial. If it is for a review mention feature not present, it could call the notify product manager. So different functions can be called based upon the result of the review. So this is overall scenario that we want to do, and for that, for creating a demo program, we will use the Google's Gemini model, because it is free to use and API is available there, and you can use that API. It is a top tier multimodal model and free through Google's AI Studio. But requirement is that you must have an API key. So to get an API key, you can go to Google AI Studio at this particular website, aistudio.google.com. Open that site. You have to sign in with your Google account, and I am expecting that everyone have Google account. Then you will click on get API key, and then you will click on create API key in the new project. Then you will copy the key, keep it safe. Okay, so let me show you the screenshot. So when you open that particular site, on the left side you can see the button that is get API key. When you click on this button, a new page will open, and on the new page you will see this button, create API key. When you click on this button, you will get this kind of screen. Here you will see a small text box. When you just click on this text box, a drop down menu will open, which will show you some pre-existing API keys that are already developed by the Google system for you. So you can select any one of these. So for example, in my case, I am getting these two values, but in your case, the values can be different. So you can select any one from these two values, and when you click OK, you will see the API key on your screen. Just copy the generated key. Okay, now am I able to send the chat? Yes, now I am able to send the chat. I want to share my code for this particular demo. I am going to share this in the chat window. You can copy it, open that particular code, and then save it in your drive. Okay, so that you can be able to run the code yourself. So I am sharing the code in the chat window. You can open this code in your laptop or in your desktop, whatever you have with you. You can just copy the code, open the browser, copy the link from the chat window, open the browser, and you can see my program, which is in Google Colab. Maybe some of you have not installed Google Colab in your drive. You need to install that application also if required. Otherwise, if you have already used Colab, then maybe chances are there that you have already installed the Colab. But if not, you can easily install the Colab from the extensions of Google. And once opened, just tell me. You also need to create the Google API key. Also, open the web page and create a generator key. Okay, when ready, tell me so that we can proceed further.
Yes, sir, it is open, sir. Google API key in environment.
Okay, just copy the generated key. Once the key is copied, now you have to open this particular file that I have shared. Just click on the file. Click on the file. Click on the file. You will see an option to save a copy in Drive. Click on the file and then select save a copy in Drive. Click on this file icon, file menu. Click on this file menu and select save a copy in Drive. You will see in the middle of the menu save a copy in Drive. That will save my program into your drive. Then you can run it from your local drive. Okay. So on the right side you will see connect button. Just click on this connect button. On the right side, you will see the connect button. Click here. Click on the connect button. And on the left side, you will see this particular icon, key icon. On the left side, you will see this key icon. In key icon, there will be a text box. You can give any name. I have given the name Google underscore API underscore key. You can give it any name and paste your key here. In the value part, you have to paste your key. Okay, when this step is done, inform me. So you need a laptop for this or desktop for this. It is not possible to do it from the mobile. So those who are doing it from the mobile, it is not possible for them. You need system for this. First of all, you need to create Google API key that can be created from the site Google AI Studio, which is aistudio.google.com. So you have to visit this site, click on login into site using your Google username password, click on get API key, then create API key, then this window will open. You have to select any one from the existing key, click on any one and it will show you the key on your screen. Copy that key and come to my program. In my program, you have to first of all click on the file and save in local drive. After that, click on the key button here, click on the key button here. It will open this kind of window where you can provide the name and paste your API key value here. You have to paste your API key value here and you can give any name here. By default it is Google API key. You can change it and you can leave it as it. Okay, so whatever the name you give here, same name you have to change here. If you change the name here, then you have to change here also in the code. Okay, so once done, just inform me so that we can proceed further. So once this step is done, now let us see what is see, think and integrate here in this program. It works with the following steps. We have see part, we have think part and we have integrate part. In the see part, we prepare the figures shared by the user for visualizing along with the review text and a prompt. And in the think part, it is the part where the model reasons and produces the structured output. And in the integrated part, where the AI structured insight are combined with the real world workflows display the step with formatted images, make it directly usable for the business dashboard or further automation. So let's see how it handles the image. For handling the image, as I don't have the actual access to any e-commerce site, so what I do is I manually collected few reviews along with the URLs of their images in a data frame. So that is done from the Amazon site. So from the Amazon site, I collected some customer reviews about some products and along with their images. Now from data frame, each review row contain an Amazon product image link in the column image URL, and we download the image file into the memory. So what I do is I created a data frame having two columns. One is the text part and one is the URL of the image part. So one part is the web URL of image and text part contains the review of the product. So I have five entries for this particular data frame. And from the URL part of the image, we need to fetch the URL. We need to fetch the image. To download the image file into the memory, we use the request library, and in the request library, using the get method of that library and passing the URL into it, we get the data into a variable that is called RES, response. Okay? After getting the data in the response variable has an important variable that is called content. So the content variable of response object contains the raw binary image data. Now we need to convert that into the Python image object. For that again we use image class of Python and .open and pass the bytes IO. Whatever the raw image in the response object, that raw image is converted into the bytes, and from byte it is converted into the image object, and from image object it is transferred to the IMG image variable. Now IMG is a proper in-memory image that your program can manipulate or pass to the Gemini model. So once we have image and text in our memory, we can pass this particular data to the Gemini model. Now to pass the data to the Gemini model, we need to create a prompt. So prompt is like we part this particular text. This text says that you are an expert product review analyst for an e-commerce company. Your task is to analyze the user review, which consists of an image and text. So look carefully how I design my prompt. So prompt designing is very important. If you create a wrong prompt, then the system will produce the wrong output, and the system will generate the output which may not be usable by the next program. So developing a prompt is very much easy. Carefully examine both to understand the customer's feedback, and based upon your analysis, provide a structured JSON. So this is important part. Response that conform to the following schema. Do not include any other text or markdown formatting in your response. So this kind of prompts are very important. So what we are doing here is, this prompt is very crucial. This is because it controls how Gemini understands the task and whether the model output can be reliably passed or validated or not. This prompt tells three parts to the Gemini. First is the role. As I write, you are an expert product review analyst. So we set the role and behavior and tone for the model. Now second part is the task to be performed. So I asked in the prompt specifically to look at both the image and text. That means I asked the system to combine them into a multimodal reasoning. And finally, I asked the system to format the response only in JSON and exactly follow the schema you give it. So I provide the schema like this one. So this is the schema that I have provided to provided in the prompt, and ask the system to provide structured response conforming to this particular schema. And further I restrict it not to include any other text or markdown formatting in your response. Because if you are including the text, that means you are creating unstructured data. So that unstructured data cannot be used. So I strictly tell my model to produce the format and I also provide the format. I mean, what I need, that is also given to the system. So that can be done by the Pydantic schema into the prompt. So what you see in the prompt, this one is basically a Pydantic schema. How to declare that we will discuss in the, I will show you in the code. Then finally think of the prompt as the exam question. It is again because prompt is very much important. So if you ask a student to explain photosynthesis, what you will get? You will get a free form essay. Someone write two sentences of answer. Someone may write 8 sentences. So someone write paragraph, someone write pages. But if you ask the question, list 3 steps of photosynthesis in bulleted point, then you will get the output as a structured output. That will be usable answer. So that is exactly what our prompt does to Gemini. It forces the answer into a shape that your code can trust. Okay. Then structured output, we have already discussed that whatever the response.text part that is generated by the Gemini, that is basically raw text. So that raw text need to be converted into the JSON format, into the structured format, and that structured format can be done with the help of schema. You need to define the schema that governs the expected output structure. Okay, so we will be using the Pydantic model for defining that particular schema. So this is the schema that we are going to give to the prompt. So this is the Pydantic schema. Here we are defining what are the fields. The fields are that one field is sentiment, another is defect visible, third one is issue summary, fourth one is defect category, third next is suggested action, then damage type, and then damage severity. And these are the values that we are getting. So for this we need to use the Pydantic model. Pydantic is basically a library. Pydantic is a library that is available in Python. All you need to do is create a class. You can give any name to the class, and this is the inherit from the base model. Now base model is a Pydantic model that is already defined in the system, and you are inheriting your class from the base class, and all the capabilities of base class is now available in the review analysis. And in this particular class we just declare the variables along with their data type and the possible values. For example, the variable is sentiment and the possible values are positive, negative and neutral. Variable is defect visible and the possible value is boolean, which can be true or false. Variable is summary, possible value is a string which is producing the summary of all the analysis done by the Gemini. Variable is defect category, having the values manufacturing quality, shipping damage, design flaw, user error. Then suggested action like flag for review, refund, replace, repair, add to testimonial, notify. So values of this particular variable comes from this particular list only. So damage type is this one, scratch, tear, stain, crack, missing part. And damage severity, it can be minor, it can be moderate, it can be severe. So we ask our system to provide only this kind of information by providing this particular Pydantic model. So now once we get the JSON format, once we get the response from the Gemini, that response is in the text format, and that text format is converted into the JSON format by simply one line. The analyze data is equal to JSON.load JSON response. Then we finally validate the analysis using this particular Pydantic structure. The Pydantic library also creates the JSON format as well as it validates the analysis. So if all the field match the expected type and allowed values, then it will produce a success. Otherwise, it will produce a validation error that can be used for further debugging the program. Finally, we convert the validated object back to plain dictionary using the command validated analysis.modelterm. And now we have saved schema validated dictionary that you can store or display or feed into downstream system. So finally, we have result handling. Because I don't have any downstream system, what I have done is I display all the data on the screen in a HTML page. So I simply create a HTML page and display all the data on that particular page. That's how I handle the result. But in actual scenario, based upon the results of the JSON like this one based upon these values or these values, system can decide suggested action. System can decide some suggested action, and based upon the suggested action, we can trigger the appropriate function. That can be done. But for the demo purpose, I just display the output on the HTML page. That output can be displayed by combining the original data frame and the final data frame that we received and displaying it on the screen. Okay. Now I will show you the screen. So if you are able to download this, then just run these parts. First of all, we need to have a Google key. Then we need to install all the required libraries, which include Google Generative AI, Pydantic, and Pillow. If they are not available on the system, they will be installed by using this command. Then we have, I hope it is visible to everyone. Then we have
Yes, sir. Yes, sir. Yes, sir.
all the coding part. We have to import all the required libraries here, and then we have to import we have to do the configuration part where we use the Google API key, and then finally we start our task defining the structured output, which is the think part. As you can see in this particular program, we have created a class review analysis. I defined various variables. One is sentiment, is defect visible, is summary, defect category, and along with the possible values, that these values should be there, along with the field attribute which contain the description that this particular variable is for overall sentiment, this particular variable is value true if a product defect is clearly visible in the image, and so on. These description will be used by the Gemini API for creating the outputs, and after defining all this class, we will send the image and text to the Gemini. This is the C part. The C part of our model. We define a function analyze product review, and let me run this also, and then this is our analyzing part. First of all, we declare a prompt instruction, and then we provide review analysis dot model JSON schema. Now, what is review analysis? Review analysis is basically our this one. So this is the class that we have already created. And then in the analyze part, we create the prompt, and then this is to call the model. Generative AI, we will call the model into our variable model, and then pass the model our content. So this is how you pass the data to the model, which is prompt instruction plus review text plus image. So we are combining all three parts of prompt instruction as well as review text as well as image, and then pass this to the model. So model will analyze all these things and produce the response. From the response will be in the simple text format. We have to convert that response into the JSON format. So using these commands, I am converting the response into JSON format. And finally, we will validate the response. If the every field is correct, then this will produce the output, and the result will be analysis successful. Otherwise, if there is some error, then the exception part will be invoked, and it will be help you to debug the output. Then finally, in the main part, because as I discussed earlier, because I don't have any access to the any e-commerce site, so what I have done is I manually copy pasted all the reviews from the data along with their URL of the images, For example, this image is for the first review, second image is for the second review, and so on. So I create the data and I create a data frame from this particular information. So what I have done is I have now image along with their review. Okay, then I call this one method URL. We will get the image. Then using the request method, I fetch the image from the data and then convert that image into machine readable form, and then call the analyze product review method, passing the image and review. So image and reviews are passed from here one by one to this particular method, and in this method when we pass the review and that review text and image is passed to the model from this particular pass along with this particular prompt also. So all the three parts are passed to this, and one by one every image is analyzed. Finally, when we get the result, then we combine the results and then display the result in a HTML page, simply HTML page. But in actual practice, you can call the actual function. So as you can, if you can run this program will pass all the values, all the, you can say, images and text one by one and analyze. As you can see now, the first analysis is okay. It is now analyzing second image, now analyzing third image, and so on. So we have 6 images and 6 outputs. We are expecting 6 outputs. So one by one, it is sending image and text to the ChatGPT, not ChatGPT, it is Gemini. We can use the ChatGPT also, but that is not free. If you are willing to pay ChatGPT, then you can use their API to perform the similar task. Okay. Finally, all the results are available. As you can see, in the first review, the review is positive one. So this review is positive one. This is the image of the review, and the sentiment that as detected by Gemini, it is positive. And is defect visible? False, because there is no defect in this case. Issue of summary is review positive. Now this is the summary generated by the ChatGPT or Gemini. This is the review given by the by the customer, and this is the summary generated by the ChatGPT. Defect category not applicable. Suggested action add to testimonial. So this is the function that we need to call. If the review is positive, then we will add to the testimonial on our website. Damage type is none, diversity is 0. Okay? Then in the second part, the product has too many scratches all over the body. It looks like a used item, very disappointed. So you can see there are scratch here, and also system analyze these two things and analyze the sentiment of the review. It is negative review, and is defect visible? You can see it is outputting true. Defect is visible, and this is the summary of the system. The product arrived with numerous scratches across its surface, making it appear used and causing significant disappointment for the customer. So this is what the review generated by the Gemini. And category of the problem, defect category is manufacturing quality. System automatically identified that this is a manufacturing quality problem, and suggested action is replace. Now based upon this suggested action, we can create a function that will initiate the replacement process. And damage type, it shows the scratches, and damage severity, it is moderate. Similarly, this one, again, work as expected, but the color is much darker than what was shown in the picture. Now the user is not happy with the product, and sentiment of this particular review is negative, but there is no defect. As per the system, this product is okay, there is no defect. The received product color is darker than the advertised, so nothing applicable. So not applicable means defect category. So there is no defect category, that category is not applicable, and as per the system, no action is needed in this case, and defect type is none. Similarly, you can see third, waste of money, and open. Now again system produce the output negative, and it is true. What is true? A defect visible, yes. Defect visible is true, and you can see now system generated its own summary. The shoe's sole is severely damaged and torn near the toe area. So it is automatically detecting that shoe where the problem is. And the image shows significant wear and tear, indicating a possible manufacturing defect or low quality. So quality, it is problem of manufacturing quality, and system automatically recommend the refund of the money and citing the defect type and severity. It is a tearing of the shoe and it is very much severe. So you can see similarly for other products, you can see this product is the scratches on the screen, and this is the problem of shipping. So you can see system automatically find it is a shipping damage. Here it is again manufacturing quality. Suggestion is replacement. And the kind of problem is crack and it is moderate problem, where it is severe problem. So according to the review, according to the uh, image, system try to understand what is happening and suggest the appropriate action. Now this is another part that you have to do is there are different kind of prompts. So different kind of prompt styles. You can have instruction style prompt, you can have step by step style prompt, you can have business analyst style prompt, you have validator style prompt. What you can do is you can copy these prompts from here and replace it in your prompt part, and then see how it works. Replace all this text here and you can automatically see the different kind of output. So what I want to say is that prompting is also important part in this whole scenario. Okay? So there are another application area. Healthcare diagnostics can be used. It can be used in healthcare, and that input is patient symptom plus X-ray image, and the reasoning is compare the symptom with image finding. In e-commerce, product review analysis that we have just covered, and in education and exam grading, students handwritten answer sheet that are basically image, and exam question that is text, and system can evaluate the correctness, grammar and completeness of the system. Similarly, legal document review, that means contract, that will be a text and related case references. We can combine all these and ask the system to spot risk or missing clause. Similarly, smart agriculture, customer support automation, traffic monitoring. So you can think yourself lot of application of this kind. You can create end-to-end product using the ChatGPT or Gemini or another LLM model, and using. So concluding is that building LLM application goes beyond just sending text in and getting text out. So real world system need to understand the multiple kind of input, reason carefully and return the results that are structured and usable. Prompt matters. Good prompt guide the model toward reliable structured answer. Bad prompt on the other hand often lead to free text or incomplete response that breaks the validation part. Once the data cannot be validated, the downstream all the tasks can be a problem. So we cannot do that part if we have not any structured data. So we have to force the LLM to produce the structured data using the libraries that are already available in Python. So in future, what you can do, we can have deeper multimodalities, not just text and image, but also video, audio, sensor data, 3D models. We can combine all these systems and we can use different multimodality systems to combine all these things and explore the different areas. Then we also have domain specialized LLM. So instead of one giant general purpose model, we will see LLM trained on specific industry, like trained on the law, data trained on some medicine or education, on manufacturing or agriculture. So there are so many fields. So we can create the LLM that are specific for that particular field, so that they are more accurate. So they will have the smaller size also, because if we are creating a general purpose language model, general purpose large model, then the size of that large model will be much large. So to reduce the size also, we can have specific domain specialized LLM. So we are moving from AI as a text generator to AI as a thinking partner that can see, analyze and act. So in the earlier years, What AI is? AI is just a text generator, but now it is our thinking partner. In future, we will see trustworthy, multimodal, and domain-specific AI that integrate seamlessly into the real world. So that's all from my side. Any doubts, any questions from the audience? And I hope you are able to execute the program that I shared with you, able to understand that
Definitely.
also.
Yes, all the participants, if you have any query, any questions, to kindly share with us. So, okay, sir. Thank you very much, sir. So,